Have you ever ordered something online that looked perfect in pictures but didn't quite match your expectations when it arrived? Maybe the size was off or the color wasn't quite right. That's exactly what happens when a machine learning model isn't evaluated correctly. It looks promising at first glance but disappoints when used in real world situations. Today, we're breaking down model valuation, the process that helps us see how well our machine learning models really perform. Think of it like trying out a new recipe. Before serving it at a big event, you'd probably test it out with your family or close friends first, right? In machine learning, we also test our models carefully before they are put to work. Here's how it works. We start by dividing our data into three sets: training, validation, and testing. Imagine you're learning to ride a bike. First, you'd practice in a safe area, training set. Then you'd test yourself on slightly more challenging terrain to see what you need to improve, validation set. Finally, you'd ride on the street or in a park, somewhere completely new, to see if you're truly ready, test set. The idea is to ensure the model can handle new, unseen situations confidently. But how can we tell if our model is genuinely learning or just memorizing answers? That's where something called cross-validation comes in. Think about picking players for a sports team. You wouldn't just watch them in one game, you would watch multiple games to see how consistently they perform. Cross-validation works similarly, checking how well our model performs across different parts of the data to ensure reliability. Now, sometimes just looking at how many predictions our model gets right, accuracy isn't enough. Imagine if you had a quiz that was way too easy. Everyone would score high, right? Accuracy alone might make the model look good, but it doesn't always reflect true performance, especially when outcomes aren't equally likely. That's why we also check metrics like precision and recall, which help us understand how balanced our model's predictions really are. Just like considering both offense and defense when evaluating a player's skills. There's also something called the bias-variance trade-off. Don't let the name scare you, it's actually pretty simple. Think about making coffee. Too weak isn't satisfying, but too strong is overpowering. Models work the same way. Too simple and they miss important patterns, underfitting. Too complicated and they might start seeing patterns that aren't really there, overfitting. Finding that perfect balance is key to making sure your model works well everywhere, not just in training. Model evaluation isn't just a one time thing. Imagine owning a car. You regularly check things like oil levels and tire pressure, right? Models also need regular checkups to ensure they're still performing well, especially as new data comes in over time. Lastly, one critical rule: avoid something called data leakage. It's like peeking at the answers before taking a test. It might give you great scores, but it doesn't mean you've learned anything. Keeping the test data separate ensures our model truly learns to handle new information fairly. Interested in seeing all this in action? Stick around. I'll be sharing a detailed hands-on case study to clearly demonstrate how model evaluation works in real scenarios. Check out the link to my full article in the description below for an even deeper dive. Stay tuned. Thank you for watching. If you found this video useful, don't forget to like, subscribe, and share.